Good morning, students. Now, in the today's video, we are going to start our chapter 3, that is motion in a straight line. And this is the starting part of mechanics. From here, we are going to study about mechanics. But before that, I want to discuss the solution of the question which I had given in the previous video for home assignment. And after that, we will start the today's topic, that is motion in a straight line. So let us discuss about the solution of the question which I had given in the previous video. And the question was, let the measurement of mass of a body comes out to be mass of the body, and that mass of the body comes out to be 10.02 plus minus 0.01 gram, and its velocity is measured as 5.5 plus minus 0.1 meter per second. So you had to find out the uncertainty or error in the state, uncertainty or error in the measurement of momentum. Uncertainty or error in the measurement of momentum of the body. Mass is given here. The absolute value of mass is 10.02 and the error in mass, that is 0.01 m. Delta m is 0.01 and delta v is 0.1. So percentage error in mass, percentage error in mass, it is equal to delta m upon m into 100, and it can be given as 0.01 upon 10.02 into 100%, and it can be written as 0.99%. This is the percentage error in mass. And similarly, the percentage error in velocity, delta v upon v into 100, that is 0.1 upon 5.5 into 100%, and it will equal to 1.8%. These are the percentage error in individual mass and velocity. Now we will find out the percentage error in combined percentage error in momentum. Combined percentage error in momentum. So percentage error in momentum. Percentage error in momentum. Percentage error in momentum, delta m into delta v upon mv into 100, and it is equal to 0.01 into 0.1 upon 10.02 into 5.5. This is velocity, absolute value of velocity, into 100, and it is equal to 2.79%. This is the percentage error in momentum. The momentum of the body comes out to be, along with the error, momentum of the body comes out to be, what is the momentum of the body? It comes out to be 55.5 into 11 55.5 m into v, that is 55.5 meter per second plus minus 2.79%. This is the momentum of the body with percentage error. So absolute error in momentum is equal to m into v into 2.79 upon 100, that is equal to 55.11 into 2.79 upon 100, and it is equal to 1.53. This is absolute error in the momentum. Now you can see the least precise quantity in mass and velocity which is given in the question. The least precise quantity is velocity, and it consists of only two significant figures. Hence momentum with absolute error is reported as momentum in absolute error is reported as momentum in absolute error is reported as, how the momentum in the absolute error is reported? It is reported as 55 plus minus 1.53, and it can be written as 55 plus minus 2 gram meter per second. Here 2 gram meter per second is the uncertainty or error in the estimation of momentum of the body. Momentum with absolute error comes out to be this one, and it is rounded up to two significant figures because the least precise value, that is velocity, is 5.5. So it consists of only two significant figures. So only in case to two significant figures, so it consists of only 1.53. It can be rounded up to 2, and in the momentum the uncertainty will be 2 gram meter per second. So it is all about this question. Now we will start another chapter, that is chapter 3, motion in a straight line. Chapter 3, motion in a straight line. Dear students, this is the starting of mechanics for class 11, and here we will study about the motion of a body. So first I am introducing you about this chapter, and in this chapter we will discuss about various topics. The gist of this chapter, the introduction of this chapter, I am giving what things we are going to study in this chapter. First of all we will describe the motion. and in description of motion we will study about rest, and after that we will study about motion. We will distinguish between the body at rest, how we can define a body at rest, how can we define a body in motion. After that, some basic terms related to it: position, position of the body, how to discuss about the position of the body; path length, that is called a distance, path length, that is called distance, and then displacement, that is shortest path. After that we will discuss these things. Then we will discuss about velocity and speed. Then we will discuss about velocity and speed. After that we will discuss about acceleration. Then we will discuss about graphs regarding the motion, how to represent velocity, speed, acceleration in different cases with graph. In that velocity time graph we will study, distance time graph we will study, acceleration time graph we will study, all these things we will study. Then we will study about relative velocity, comparing the velocity of two objects. Relative velocity we will discuss. And then certain equations, kinematic equations, certain equations for uniformly accelerated motion. For uniformly accelerated motion we will discuss certain equations. All things we will discuss in this chapter. A very interesting chapter, and the main physics, that is the mechanics, is going to start from here. So try to learn these things in detail. Various twisting of questions is done in this chapter. So we will discuss about various type of numericals also, concepts also, examples we will discuss, all things we will discuss in this chapter. So let us start the discussion. And first of all, I want to show you about this term motion. This is the starting in the name of the chapter, motion in a straight line. So first of all we will have to understand what is motion. Motion means to say that motion. How can you say that anything is in motion? How can you say that anything is in motion? Are you in motion at this time? What things are in motion? There is a great discussion over that, and this is the matter of thinking that what is motion and what is rest. And motion and rest is not a absolute quantity, it is a relative quantity. You can't say that any body is at absolute rest and any body is at absolute motion. Suppose I am saying that this is a tabletop, and here you had kept a book over here. The book is kept on this tabletop. Then you used to say that this book is at rest. But I used to say that the book is in motion, because I had already told that motion and rest are not absolute terms, they are relative terms, and motion and rest can be distinguished on the basis of the frame of reference. So we will discuss the frame of reference later on in the later discussion in this chapter. First of all, before discussing that, we will describe motion. How can you say the body is in motion? So motion is nothing. Motion is change in position of the object with time. Motion is change in position of the object with time. Motion is change in position of the object with time. Change in position of the object with time. In contrary with that, just opposite rest. Rest can be defined as rest is if a body does not change its position with time. Does not change its position with time. So here there are two things. Motion is change in position. Change in does not change in position and time. These two things are marketable. Position and time. So there is a simple question in your mind. Obviously, the students thinks about that. Okay, what is position? First of all, we will discuss about the position. First of all, we will discuss about the position. What is position? Both the terms we will discuss here, position and time. Position. What is position? Position means what? So, to describe the motion of an object, to describe the motion of an object, to describe the motion, to describe the motion, position is very must. Position, knowledge of position of the object is very must. So how can you describe the position of the object? Position means to say that, suppose I am saying that your friend had called you and he is in Delhi, so he wants to know about your position. So he had called you and asked that what is your position and how I will reach you after coming to your place. So simply you used to tell him that when you deboard at Gorakhpur railway station, then you travel 5 kilometers towards east and you reach Divine Public School, and that is Divine Public School Mohanapur is my position. Divine Public School Mohanapur. Divine Public School Mohanapur is my position. So what you had told, with a reference point, with a origin, that is Gorakhpur railway station. Gorakhpur railway station. From Gorakhpur railway station, five kilometer towards east, DPS Mohanapur. From Gorakhpur, so it is your what? Reference point. It is your reference point, or you can say that it is your origin. And from certain origin you had described your position, it is 5 kilometers. Means your friend will deboard at Gorakhpur railway station, and he used to travel. He will travel 5 kilometers towards east and reach your position, reach your destination, reach his destination, or reach your position, that is DPS Mohnapur. So this is the position. Position of any object needs to be specified with a certain landmark, which is called as the origin or reference point. And from that reference point, you can origin is can also be the origin can also be the your position. If you are situated at Gorakhpur railway station, then you will simply call him that I am at Gorakhpur railway station, which is your origin or reference point or landmark, and you will meet me at there. But if with the passage of time, if with the passage of time, with the passage of time, you know about time, that clock, whatever the clock reads is time. So if at 10 o'clock 10 a.m. you are at this position, that is 5 kilometers towards east from Gorakhpur railway station, and at 11 o'clock you are at 6 kilometers towards east from Gorakhpur railway station, means with the passage of time, with the thing what the clock reads, with the passage of time, you are changing your position. Your position is going to be changed with the passage of time. And if your position is going to be changed with the passage of time, then you are in motion. Then you can say that you are in motion. So this is the simple definition of motion. But there is another thing. If you are saying your motion with respect to an observer, then the case will be slight difference. The same thing, but there is a difference, that is called the frame of reference. We will discuss later. But if with the passage of time you remain at the same position, at 10 a.m. you are 5 kilometers away from the Gorakhpur railway station, and at 11 a.m. also you are 5 kilometers towards east from the railway station. At 12 noon you are at 5 kilometers from the Gorakhpur railway station, means with the passage of time you are at the same position, then you are said to be at rest. You are said to be at rest with respect to a particular observer. Again and again I am including with respect to a particular observer. Means observer is necessary here, and about the observer we will discuss when we are going to discuss about the frame of reference. So this is the concept of rest and motion of the object. This is the concept of rest and motion of the object. Now we will discuss about various types of, we will discuss about mechanics. What is mechanics? Because I had told you that this is the start of your mechanics. So first of all we will study about mechanics. A brief idea about rest and motion. I think all of you got clear about a brief idea about rest and motion. What is rest and what is motion? Now mechanics. Mechanics is what? Mechanics. Mechanics is nothing. Mechanics is that branch of physics in which we study about motion of the object. Branch of physics. Branch of physics in which we study about motion of an object. That branch of physics in which we study about the motion of the object is called mechanics. Now mechanics is divided into three subcategories: branches of mechanics that examine the motion of the object, branches of mechanics that examines motion of the object. Branches of mechanics that examines motion of the object. First one is statics. First one is statics. Statics means the study of body at rest and time does not play any role. Since the body is at rest, body is not changing its position, so time does not play any role in this case. And the branch of physics in which we will study about the body at rest is called as statics. And the next one is kinematics. Next one is kinematics. 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 It describes the motion of the object, the motion of the object without knowing the cause of motion. Without knowing the cause of motion. In the kinematics, we just study about the motion of the object and not going to bother about the cause of motion. What is the cause of motion? What forces are responsible? Why body is accelerating? Why body is changing its velocity? All things we are not going to bother about. Only we are going to bother about the only we are going to bother about the motion, how the motion is going on, not on the cause of the motion. And time factor plays an important role. In this case, time factor plays an important role. Means in this case, the position of the body is going to be changed with respect to time. Position of the body is changing with respect to time. So it is called as kinetics. So time factor plays an important role. Time factor is included in the study of such type of motion. While in statics, time factor does not play any role. With the passage of time, the body is not going to change its position. But in kinematics, with the passage of time, the body is going to change its position. So time is also included. Along with the position, time is also included in the study of such type of motion. And the next one is dynamics. Next one is dynamics. Next one is dynamics. Third one is dynamics. And in case of dynamics, it relates the motion of the object. It relates the motion of the object with the forces which causes them, which causes them. In this case also time factor plays an important role. Time. Dynamics. In case of dynamics, we will study about the forces. What forces are responsible for the motion of the object, and that forces, study of that forces. So in the next chapter we will study about the dynamics, that is Newton's laws of motion. In the next chapter we will discuss about this dynamics, about the dynamics. In this chapter we will only study about the kinematics and the statics, that is motion in a straight line, and in this chapter we will discuss only the motion which is causing in a straight line, motion in a straight line. Only we will discuss whatever the motion of the object which are collinear or which is in the straight line, that type of motion we will discuss. In the next chapter we will discuss about the motion in plane, that is two dimensions. On the basis of this we had divided the dimensions: one dimensional motion, two dimensional motion, and three dimensional motion. So in the next video we will discuss about what are one dimensional motion, what is two dimensional motion, and what are three dimensional motion. So this is all about today's video, students. Thank you, students. Go through these videos and try to study, and in the next video we will discuss about the various types of motions, the classification of motion on the basis of dimension, and then we further continue our discussion. Thank you, students, and have a nice day. Take care.